Students, let's look at the first question over here. The question is like, position of a particle in a rectangular coordinate system is 3, 2, 5, then its position vector will be. So we have to find out what is the position vector. Now what is a position vector? It is a vector which describes a point in a coordinate system. Usually it is with respect to the origin of the coordinate system. Okay, so to answer this, let us first make the question simple by taking only two axes. Let us take x-axis and y-axis. Since we are taking only two axes, let us only worry about 3 and 2 over here. So let us say this is 1, 2, 3, 4, etc. along x-axis. This is 1, 2, 3, 4, 5, etc. along y-axis. Okay. Now where is the point 3, 2 in this coordinate system? 3 along x-axis, 2 along y-axis. So this is the point. Let me call that as A. Now a vector which goes from the origin to that point is a position vector of point A. Let us try to write what is A vector. A vector is equal to, we have to write how much it spans along x-axis, how much it spans along y-axis. So it spans 3 units along x-axis. So 3, let me write 3 here. Along x-axis, I have to write that in mathematics language. So it is I cap. I cap is a unit vector along x-axis. Plus, it spans 2 units along y-axis. So 2. Unit vector along y-axis is j cap. Okay. Now, in the question there is third axis also, z-axis, right? So we just have to extend this for the third dimension. Like, if there was third axis as well, then we should have written vector A as, it spans 3 units along x-axis, 3 I cap, 2 units along y-axis, so j cap, 5 units along z-axis, so 5, unit vector along z-axis is k cap. Okay, so this is the answer. So the right answer for this question, or right option for this question, is option A. Moving on to the next question. The question is like, a force of 5 Newton acts on a particle along the direction making an angle 60 degree with vertical. Its vertical component will be. So let us visualize it by using a diagram. So there is a coordinate system, let us say. There is a force which is acting at an angle of 60 degree with vertical. So this is vertical, 60 degree vertical, meaning let's assume that this is 60 degree. There is a force acting here. This is the force, right? Now we want to find what is given here. The magnitude of force is given. So magnitude of this force is 5 Newton, let us say. We have to find out its vertical component. Vertical component meaning, if you drop a perpendicular to y-axis, so this becomes its vertical component. Okay, so we will have to find out this. You must have learnt in trigonometry SOHCAHTOA rule, right? SOHCAHTOA. This is sine, this is opposite, hypotenuse, this is cos, this is adjacent, this is hypotenuse, this is tan, this is opposite, this is adjacent, right? Now you see, this angle 60 degree is adjacent to this line. Don't you think so? So we have to use a relation corresponding to the adjacent side. So this relation has to be used. So you know that cos theta is equal to adjacent divided by hypotenuse, right? Now how do I name this adjacent side? Since it is along y-axis, let me name it as Fy. Okay, this is the magnitude of it. F is just the magnitude of it. Okay, so hypotenuse is equal to the magnitude of F. So we want to find out what is Fy, right? So Fy divided by magnitude of F. Let me just write it like this. Okay, so theta you know is 60 degree. Now let us do the substitution. Cos 60 into F is equal to Fy. Cos 60 is half into magnitude of F is 5 equals Fy. So Fy is equal to 2.5. So the right option over here is 2.5, or option D is right here. Let's move on to the next question. Next is, A is a vector with magnitude A. Then the unit vector A cap in the direction of vector A is. So we will have to find out what is the unit vector A. Let us first understand what is the meaning of unit vector. To do that, let us consider a vector A. This is, let us say, vector A. Let's say the magnitude of this vector is 5. Since I have written it along x-axis, the direction is also I cap here. So this vector is 5 I cap. Okay. Now what I am going to do is I am going to divide this into 5 pieces. Alright. So 1, 2, 3, 4 and 5. Okay. Let's assume that these all the 5 pieces are equal. Although it's not visible in this diagram, let's say that all the 5 pieces are equal. Okay. Now what do you get? You get 5 vectors like this, right? 3, 4 and 5. Each unit over here, each vector over here is called as a unit vector. So in layman's language, the meaning of unit vector is just a small unit of a complete vector. Now, how do I define that? Unit vector, since this is vector A, unit vector of A, I am going to represent it as A cap. What did I do? I took a vector, right? Vector A I took. I divided it into number of parts which is equal to the magnitude of it. Right? Here it is 5. How do I write magnitude? Magnitude of A. Don't you think so? So a vector divided by its own magnitude is nothing but a unit vector. That is what they are asking. And what is the direction of this unit vector? It is also along the original vector itself, vector A itself, or it is at least parallel to it, right? So the right option over here is vector A divided by magnitude of it, right? So D is the right option here.